Education, education, baby. Come on, education has no end.
How are you, students? Welcome to another lesson on the trends across period 3 elements. The elements in period 3 are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. They each have 3 occupied energy levels. The elements show gradual change in both physical and chemical properties. So that is the introduction part of the trends and properties across period 3. Now we are going to look at the physical properties, the trends in the physical properties. Then we shall look later at the trends in chemical properties. Now, trends in physical properties. The first trend we are going to look at is the atomic radius. The atomic radius decreases across the period. Learn decreases across the period due to increase in the number of protons that lead to an increase in nuclear force of attraction of outermost electrons towards the nucleus, hence decreasing the atomic radius. Therefore, sodium has the largest atomic radius. So, according to the atomic radius, as we move across the period, there is an increase in the number of protons. That one you know. And that one increases the attraction between the nucleus and the outermost energy levels, making the atomic radius smaller as we move across the period. Trends in bond type. Sodium, magnesium, and aluminium have a giant metallic structure with strong metallic bonding. Now, silicon has giant atomic or covalent structure with strong covalent bonding. Now, the next one is phosphorus, followed by sulfur, chlorine, and argon, which all have simple molecular structures with very weak van der Waals forces between molecules. Now, the next trend we are going to look at is the melting point and boiling point. Now, we begin with sodium. Magnesium and aluminium are metals. They have the metallic bonding with giant metallic structure. Going from sodium to aluminium, the atomic radius decreases and the number of delocalized electrons increases from 1 to 3. So the strength of the metallic bond increases across the period. Hence, melting and boiling points increase across the period. So I hope you've understood that the melting and boiling points involve the bond type. So the first 3 elements are metals, but their melting points are not the same because of the strength of the bonds holding the different metals together. So we expect sodium to have a weaker metallic bond than aluminium because the strength of the metallic bond increases as we move across the period due to the increase in the number of delocalized electrons and also due to decrease in size. Increase in number of delocalized electrons and decrease in the size of the atom. Now, the next trend we are going to look at is ease of cutting. How easy is it to cut that particular element? Now, the ease of cutting decreases across the period due to increase in the strength of the metallic bond with increase in the number of delocalized electrons. So as the metallic bond becomes stronger, then it is hard to cut through that material. Hence, sodium is easiest to cut with a knife, while aluminium is the hardest. Now the next trend we are going to look at is electrical conductivity across the period. Now sodium, magnesium and aluminium are good conductors of electricity due to presence of delocalized electrons, but the conductivity increases across the period due to increase in the number of delocalized electrons. Let us now look at silicon. Now we find that silicon is a metalloid. A metalloid is a substance that has both metallic and non-metallic properties. So silicon belongs to that group of substances called metalloids. It has a giant atomic structure with strong covalent bonds. It has a high melting and boiling point because the silicon atoms are held together by strong covalent bonds. So that is it about silicon. It's a metalloid with a giant atomic structure which involves very strong covalent bonds. It has a high melting and boiling point because the silicon atoms are held together by very strong covalent bonds. Now let's look at phosphorus, sulfur, chlorine and argon. Now these are nonmetals and they exist as small separate molecules. Phosphorus, sulfur and chlorine exist as simple molecules, just molecules with strong covalent bonds between their atoms. Argon exists as separate atoms. It is monoatomic. Their melting and boiling points are very low. The reason is because the molecules are held together by weak van der Waals forces of attraction, which are very weak bonds and easily broken by little energy. Sulfur has a higher melting point than the other three because phosphorus exists as tetraatomic P4 molecules. So those are 4 atoms in one molecule. Sulfur exists as octaatomic S8. Those are 8 atoms of sulfur binding together. Chlorine exists as diatomic molecules, that is 2 atoms of chlorine bound together to form a molecule. And argon exists as monoatomic, just an atom molecules, yani they exist as atoms. Argon exists as atoms. Now the strength or number of van der Waals forces decreases as the molecular mass decreases. Therefore, a smaller molecule will have fewer number of van der Waals forces or less strong van der Waals forces. Therefore, the melting and boiling points decrease in the order of sulfur 8, greater boiling point and melting point than phosphorus 4, with a greater boiling and melting point than chlorine 2, with a greater melting and boiling point than argon. Now, when I say S8, I just mean that is a big molecule with 8 atoms combined together to form a molecule. So, the van der Waals forces in that molecule are stronger, or they are many than the ones in phosphorus 4, which are 4 atoms of phosphorus combined together to form a molecule of phosphorus, which is still stronger than the one for chlorine, which has only 2 atoms combined together. And finally, argon has the least melting and boiling point. Now let's look at some sample questions from this section. So the first one, explain why chlorine has a higher melting point than argon. So the answer for that question should be chlorine is diatomic molecule while argon is monoatomic. Therefore, chlorine has stronger or more van der Waals forces than argon. As simple as that. Question number 2. Explain why phosphorus is a solid while chlorine is a gas at room temperature. So the answer should simply be phosphorus is tetraatomic while chlorine is diatomic. Hence, phosphorus having a higher molecular mass has stronger or more van der Waals forces than chlorine. So in these questions, we are only talking about the size of the molecular structure which contributes to the stronger the van der Waals forces. If it is bigger molecular mass, then a stronger or more van der Waals forces, and vice versa. Then question number 3. Explain why sulfur has a higher boiling point than phosphorus. So I've just told you that sulfur exists as octatomic molecules, that is S8, while phosphorus exists as tetraatomic, that is P4. Therefore, sulfur has stronger or more van der Waals forces than phosphorus because it's a large molecule. Now, something to note which we had not noted earlier is that silicon is a semiconductor. Phosphorus, sulfur, chlorine, and argon are poor conductors as they do not have delocalized electrons in their structures. So it is important to note that. Now that marks the end of our lesson. Hope you've been attentive enough and you have been able to understand every point. Let us meet again in the next lesson. Cheers.
Education, education, baby. Come on, education.